Hi, I am Subalingam, an undergrad at IIT-Delhi, and in the next 5 to 6 videos, I will be talking about this chapter called Aldehydes, Ketones and Carboxylic acids, that is Unit 12 of Chemistry Class 12, CBSE. Let's look at some basics before getting into the chapter. So, introduction. In this unit, we will study about the organic compounds containing carbon-oxygen double bond, and these compounds or these groups are called carbonyl groups. In aldehydes, the carbonyl group is bonded to a carbon and hydrogen, while in the ketones it is bonded to two carbon atoms. So the one on the left is an aldehyde where the carbon is bonded to hydrogen on the right, and one on the right is ketone where the carbon is bonded to two alkyl groups. So the general formula of an aldehyde is RCHO or ARCHO, and for ketone is RCOR dash and other variants like ARCOR dot dot dot. The carbonyl compounds in which the carbonyl group is attached to oxygen are called as carboxylic acids, and we represent these by RCOOH. That is, the carbon of carbonyl group CO is attached to OH, that is an hydroxyl group. By the way, carboxylic acids have different properties from carbonyl groups, carbonyl compounds. By carbonyl compounds, I mean only aldehydes and ketones. Carboxylic acids and their derivatives that we will see soon have separate properties and are not considered as carbonyl compounds. So their derivatives include esters and anhydrides. The one on my left is anhydride, where I have RCOOCO dash, and one on my right is ester, RCOO dash. In compounds where carbon is attached to nitrogen is called amides, and the carbon attached to halogen we call it acyl halides. By the way, here carbon means the carbon belonging to the carbonyl group, that is C double bond O. So this is the one on the left is acyl halide, one on the right is amide, RCOX and RCONH2 respectively. And again I am saying that carboxylic acids are different from carbonyl compounds. By carbonyl compounds I mean only aldehydes and ketones. We will start with carbonyl compounds, that is aldehydes and ketones, and in the second half of the chapter we will study about carboxylic acids. So we will start with nomenclature of carbonyl compounds, and in that first with common names. The common names of most aldehydes are derived from the common names of the corresponding carboxylic acids by replacing the ending IC of acid with aldehyde. At the same time, the names reflect the Latin or Greek term for the original source of the acid or aldehyde. The location of substituent in the carbon chain is indicated by Greek letters alpha, beta, gamma, delta, dot dot dot. The alpha carbon being the one directly linked to the aldehyde group, beta carbon the next, and so on. So we have acetaldehyde in the first, that is CH3CHO, then benzaldehyde, and in the third compound notice beta bromo. Why beta? Because the bromo is attached to the second carbon from CHO group. So let's move on. The common names of ketones are derived by naming two alkyl or aryl groups bonded to the carbonyl group. The locations of substituents are indicated by Greek letters like alpha alpha dash, beta beta dash, and so on, beginning with the carbon atom next to the carbonyl group indicated as alpha alpha dash. Some ketones have historical common names, example dimethyl ketone which is called acetone, dimethyl acetone dimethyl ketone is CH3COCH3. We have methyl group on either side of carbonyl group. So it's called dimethyl ketone. That is also called acetone. Alkyl phenyl ketones are usually named by adding the acyl group as prefix to phenone. So we have the examples starting with acetone CH3COCH3, then acetophenone, and so on. Now let's look at IUPAC names. That is very important. Yeah. The IUPAC names of open chain aliphatic aldehydes and ketones are derived from the names of the corresponding alkanes by replacing the ending E with Al and ONE respectively. So we use Al for aldehydes and ONE for ketones, and we remove the E. In case of aldehydes, the longest carbon chain is numbered starting from the carbon of the aldehyde group, while in case of ketones, the numbering begins from the end nearer to the carbonyl group. Example: CH3CHO is called ethanol. We start the numbering from the right, that is the carbon of the carbonyl group, and we move towards the left. Since there are two carbons in the root word, the one belonging to CHO, the other from methyl group, it's called eth, and it's an aliphatic compound, so it is ane. We remove the E, and it's an aldehyde group, so it's called, we add Al as suffix, so it's called ethanol. The substituents are prefixed in alphabetical order along with numerals indicating their positions in the carbon chain. So suppose we take this compound. Let's try to name it. We have to go from right because CHO is more preferred. So we start numbering from the right, 1, 2, 3, 4, 5, 6, 7. And we see that bromo is attached to 4th carbon, and the methyl group is attached to the 3rd carbon. So since we have two substituents, we follow the alphabetical order and we give numbering, that is 3 methyl and 4 bromo. Since B comes first, we say it as 4 bromo 3 methyl heptanol. I hope it's clear. The same applies to cyclic ketones where the carbonyl carbon is numbered 1. So let us try to name this compound. We have a ketone and a methyl group. We start the numbering from the top because carbonyl group is more preferred, and we move towards right because we have a methyl group over there that must get least numbering. If we go from left, then the methyl group will get number 4. This we have seen in IUPAC naming in class 11 itself. So this compound is called 3-methyl cyclopentanone, as the methyl group is attached to the 3rd carbon of the pentane ring, cyclopentane ring. When the aldehyde group is attached to a ring, the suffix carbaldehyde is added after the full name of the cycloalkane. The numbering of the ring carbon atoms start from the carbon atom attached to the aldehyde group. So we have this compound now, a simple compound. So directly I am naming it as cyclohexane carbaldehyde. The aldehyde group is attached to a ring, so we add the suffix carbaldehyde to it, and the full name is cyclohexane carbaldehyde. The name of the simplest aromatic aldehyde carrying the aldehyde group on a benzene ring is benzene carbaldehyde. However, the common name benzaldehyde is also accepted by IUPAC to make things easier. Other aromatic aldehydes are hence named as substituted benzaldehyde. Now let's try to name a ketone having an alkyl group and an aryl group. So we take this example. So we number it as 1, 2 and 3, and the name given to this is 1-phenyl propan 1-none. That's how we name a compound having an aryl group and an alkyl group and a ketone. So hope it's clear. So now, to finish, before finishing up nomenclature, let's try to look at some more examples. So first we have this compound. There's a double bond over there, and CHO group is more preferred. So we start from right as usual, no confusion in that. So 1, 2, 3, 4, 5, and yeah, pretty simple. Pent 2 all. While 2A, the double bond is there from second to third carbon, and we say it as pent 2A if there was no there was no aldehyde group. But since there is an aldehyde group, we say it as pent 2 all after removing the E of E. Another example. Let's try to name this one. Here we have a ketone and an aldehyde. Yeah. So in this case, let's first number. It's easy. Numbering is easy. 1, 2, 3, 4, 5 because we have to start from right. And the ketone is a substituent here, and we use the prefix oxo, OXO. So we have a name 3-oxo pent and al. 3-oxo pent and al. Pentane is the aliphatic chain. We have CHO attached to it, so it's pentanal, and we have a ketone group at the third carbon, so we use the prefix oxo. So 3-oxo pentanal. Now a pretty easy one. So we have a NO2 group at para position with respect to aldehyde, and as many of you might have guessed by now, we can call it 4-nitrobenzene carbaldehyde, or we can just say it as 4-nitrobenzaldehyde because benzaldehyde is an IUPAC name. Okay, now let's look at some interesting stuff. So we have this compound. This is pretty interesting and pretty important that you learn how to name such compounds. So the problem in this is that we have 3 aldehyde groups, and all of these are the same groups. We can't prioritize one over the other. That is, we can't say you get high priority, you get low priority, no. So to get rid of this problem, we only consider the middle 3 carbons in the main chain, and so we have the numbering 1, 2 and 3. You can actually go from right to left, it doesn't matter, but for now I have gone from left to right. So now what? We have 3 carbons in the main chain, so the root word should be prop, and it's an aliphatic compound, so propan. How to accommodate these aldehydes in the compound, in the name? So this is how we are going to get rid of the problem. We are going to name this as propane 1,2,3 tricarbaldehyde. The aldehydes are attached to the first, second and third carbon. So we name it propane 1, 2, 3 tricarbaldehyde. I hope this one is clear. So let's finish up this nomenclature exercise by 3 more examples. This time I'll just draw the compound and you are going to name it. I'm not going to explain how I got the name. They are pretty simple ones and we have seen similar things till now. So this is the first compound we have. It's a ketone. We have a methyl group at the alpha position. So how do we name this? We're going to name this 2-methyl cyclohexanone. Pretty simple, right? Next compound, more simpler one. So we have 2 CHO groups this time at ortho position. So how do we name this? We're going to name this benzene 1, 2 dicarbaldehyde. Di is used because we have 2 aldehyde groups over here. So benzene 1, 2 dicarbaldehyde. The final example, that's an ether group, by the way. OCH is an ether group. We have seen this in the previous unit. And this again is an aldehyde because aldehyde is more important than methyl or ether group. So we're going to name this as 2-methoxypropanal. 2-methoxy is a substituent at second carbon. I hope the nomenclature is clear, and I am moving on to the structure of carbonyl compounds, or structure of carbonyl groups to be more precise now. The carbonyl carbon atom is sp2 hybridized and forms 3 sigma bonds. I hope you know what sigma bonds are by now. The fourth valence electron of carbon remains in its p orbital and forms a pi bond with oxygen by overlap with p orbital of an oxygen. In addition, the oxygen atom also has two non-bonding electron pairs. Thus, the carbonyl compound and the three atoms attached to it lie in the same plane, and the pi electron cloud is above and below the plane. The bond angles are approximately 120 degrees as expected of a trigonal coplanar structure. Now we will see how it looks on the plane. So this is how it looks. It's exactly the figure 12.1 from the book. The carbon-oxygen double bond is polarized due to higher electronegativity of oxygen relative to carbon. Hence, the carbonyl carbon is an electrophilic Lewis acid, that is, and carbonyl oxygen a nucleophilic center. Nucleophilic center is a Lewis base. Carbonyl compounds have substantial dipole moments and are polar than ethers. The high polarity of carbonyl group is explained on basis of resonance involving a neutral and a dipolar structures as shown. The one on my left is a neutral structure. We can draw a resonance structure like one on the right, that is dipolar. So now we have learned about the nomenclature of carbonyl compounds, then we saw the structure of carbonyl groups. Before moving on to the preparation and chemical reactions, let's study the physical properties first. So physical properties of carbonyl compounds. Methanol is a gas at room temperature. Ethanol is a volatile liquid. Other aldehydes and ketones are liquid or solid at room temperature. The boiling points of aldehydes and ketones are higher than the hydrocarbons and ethers of comparable molecular masses. It is due to weak molecular association in aldehydes and ketones arising out of dipole-dipole interactions. Also, the boiling points are lower than those of alcohols of similar molecular masses due to the absence of intermolecular hydrogen bonding. The following compounds of molecular masses 58 and 60 are ranked in order of increasing boiling points in this table. So first we have N-butane, whose boiling point is 273 Kelvin. Then we have methoxyethane, then propanol, then acetone, then propan-1-ol. Alcohols have the highest boiling points. The lower members of aldehydes and ketones, such as methanol, ethanol, and propan-1 are miscible with water in all proportions because they form hydrogen bonds with water. However, the solubility of aldehydes and ketones decreases rapidly on increasing the length of alkyl chain. All aldehydes and ketones are fairly soluble in organic solvents like benzene, ether, methanol, chloroform, etc. The lower aldehydes have sharp, pungent odors. As the size of molecule increases, the odor becomes less pungent and more fragrant. In fact, many naturally occurring aldehydes and ketones are used in blending of perfumes and flavoring agents. So with this we have finished the physical properties of carbonyl compounds, but before finishing this video, let me give you a small problem to solve. So the question is that you need to arrange the following compounds in the increasing order of the boiling points. As I'll give you 15 seconds to solve, it's a pretty simple one, and you can pause the video if you need more time, and your time starts now. So yeah, I think I've given you enough time. So now let's solve it together. By observation, you can say that the molecular masses of these compounds are in the range of 72 to 74. Since only one butanol, that's an alcohol, are associated due to extensive intermolecular hydrogen bonding, the boiling point of butanol would be the highest. Butanol is more polar than ethoxyethane. Butanol is an aldehyde and ethoxyethane is a ether. Therefore, the intermolecular dipole-dipole attraction is stronger in the former. N-pentane molecules have only weak van der Waals forces. So, from whatever explanation I have given, I will conclude that N-pentane has the least boiling points among these. Then, following that is ethoxyethane, that's an ether. Then butanol, that's an aldehyde. And the highest boiling point among these is butanol, that's an alcohol group. So with this we have come to the end of this video. To summarize, we started off with the introduction to carbonyl group and carboxylic group. Then we saw how to name the carbonyl compounds. First we saw the common names, then you saw the IUPAC nomenclature. Then we studied about the structure of the carbonyl group, and finally we saw the physical properties of the carbonyl compounds. In the next video, I would like to talk about different methods of preparing these carbonyl compounds and some of the uses. I hope the content in this video was clear and hope to see you in the next video. Goodbye.